Hi, good morning everyone. My name is Camilla, and today we're going to talk about stacks and how we can implement it through linked lists. Now, first we have here a code in our NetBeans, okay, and let's try to run. And we can see that this is the output. Now, what we're going to do today is we're going to trace how the compiler got that output. So we also need to think like a compiler and trace the code line by line in order for us to know why we got that output. So first things first, let's open this one so that the code will be much more visible. And then, as always, the compiler will always read first the code that's inside our main method. So inside our main method, we have a object creation of SLL and a instantiation of stack as linked list. So it will trigger this class which has the same name, stack as linked list. Now inside this class we have a stack node and we declared root, and another class that is the same name, stack node, so it will also be triggered. Now the whole purpose of this code right here for this class is to create a node, because when we are using linked lists, we are using nodes, not indices, unlike array lists or arrays. Now when we go back to our main method, we're going to call the push method. Now inside the push, as we call the push method, we also put a parameter of 10 there. Now we jump to the push method. Alright, we jump to the push method, and inside the parameter, that integer data, that value in that data will be 10, because that is the value that we have passed through earlier. Now we did another instantiation, stack node. Now we are going to jump back to stack node with the purpose of adding a new node. So we have called that class. So we now have a node. We now have a node to put our value, which is 10, because again the parameter of data is 10. Now we have a conditional statement here that we are to continue if our root is equal to null. Now earlier we declared a root, but we did not put any value in it. So it's safe to assume that our root would still be null. Yet, now when we go back, root is equals to null, so which means this code right here, this condition is true. That means we get to proceed to the code which is inside the if statement. So we put root in our new node. So the new node that we have created, we point root there. And after that we implement the next code outside our conditional statement, which is this in .out.print. So we are going to print the value of data, which is 10, and push the stack. So that's why we got the first line of output, 10 push to stack. Now again we do the same process to the other one. We do another push. We call the push method, and then our parameter here would be 20. So again we do exactly what we did earlier. We go to the push method. Our data now from 10, it will become 20. Since there is an instantiation, we then again jump to that specified class, which is stack node, and we add another node. So now we have 2 nodes. Now again we go to the conditional statement that we are to continue if the root is equals to null. But we already set the root to the new node that we created earlier. So that means our root is not null anymore. So Let's erase this, and let's just put the value of our parameter here, which is 10. Because that is 10 earlier. So the if statement is now false. So we skip that, we jump to the else statement. Inside the else statement, we have stack node, and we declared the new variable temp, and again we equal its value to also to the value of root. So currently our root is pointing at 10, the very first node that we have created. So two of them are pointing at 10. Now the next step is to point the root to the new node. So like I said, we have two nodes already. The first one is 10, the other one has 20. We are going to point our root to our node. We're going to point the root to our node that has the value of 20 inside. 20, and temp will remain at the old node that we did earlier, which has the value of 10. So root is now on 20 and temp is still on 10. Now the next step is the new node that we had created, the node that has the value of 20. We will link it to the previous node. So we will link it. It says here new node.next is equals to temp. So where's our temp right now sitting? So our temp is sitting at number 10. So from 20 we point our arrow to visualize this more. We point our arrow to the node of 10. Then after that, again we print out the value of data. So right now the value of data is now 20. The value of data is now 20, and we print the statement push to stack. So that's why we got the second line of output, 20 push to stack. Now after that, we go back to our main method and again call the push method, and this time we pass through the value of 30 as a parameter. Now we're just going to trace here and see it's pushed. Now our data from 20, we're going to erase that. We are going to erase that, and we're going to change that to 30. So again, we did another instantiation, so adding a new node. We add a new node. So currently we now have 3 nodes. So that's 10, 20, 30. And this time we're going to run it again to the if else condition. Now again, it says here that we are to continue if our root is equal to null, or in other case, if our root has no values in it. So our root earlier has 10. Now it is pointed to 20. So we're gonna change that to 20, just so we can visualize it more. And that makes our if statement false again, because our root has a value, it is not null. So again, we jump to else. Create another node, another temp, just like we did earlier, and we point our temp to our root. So our current root is still pointing at 20. So that means if we equal the value of temp to the value of root, that means both temp and root are pointing towards the second node that we created, which has the value of 20. Now the next thing that we are going to do is move the root. So we move the root to the new node that we have created. So from 20, we're going to move this to 30, because that was the newest node that we created. And then after that, new node.next is equals to temp. Now after that, we link our newest node to the temp. So we link 30 to 20 because our newest node has a value of 30. Our temp still currently sits on our second node, which has the value of 20. So we put an arrow there, right? We can visualize it here clearly, and that is how our linked list shows. So then after that, system.out.print, we print again the value of data. This time we erase 20 and we put in 30, right? 30, and the text push to stack. So that's why we got the third line of our output, which is 30 push to stack. Now again we go back to our main method and we perform the rest of the code. Now the rest of the code, we do a print statement. Now inside the print statement, we call the pop function. It's the same, as you can see, it's the same as earlier. The only thing is we are not passing any parameter, any values, and we called a different method, the pop method. So the difference between push and pop: push, we are adding a value to our list. Pop means we are popping away values, like we're taking away values from our list. Now, since this is a pop, our pop method is right below our main method. So let's just connect it here so that we can further visualize it. And then inside the pop method, we declared the value, the integer type variable pop, and we initialize it to integer that minimum value. So what that means is we initialize our pop to the lowest possible value that we can. So why do we do this? It is to avoid underflow in our list, because what happens is if you continue popping values in your linked list, even if it's already empty, then that will result to underflow. So that's why we have set our pop to the lowest possible integer that we can. Now next line of code is another conditional statement where it says that we are to continue if our root is equals to null. Again, our root is not null. So this if statement is false. So the purpose of this statement here is just to check if our stack is empty. Now considering that our stack is not empty, then we will go back. We will jump to else. What is an else? Now, inside the else condition, inside the else statement, we set the pop to the root to the data that is in the root. Our root currently sits on the newest data that we have, or to the newest node that we created. What is in our newest node? It is 30. So the value of pop right now is now 30, and root, we set it to root.next. And after getting that value, after putting that value 30 in our pop, after putting the value 30 in a pop, we now point the root to its next node so that we can now pop the first node, which has the value of 30. After that, return pop. So we return to our main method, and the value of our pop right now, and the value that we have returned from this statement is 30. So that's why we got the next output, which is 30 pop from stack. Alright, so now let's proceed to the next. Let us now proceed to the next line of code. Again, system.out.print with another print statement. So we print the text top element is, but we need another method call. So earlier we used pop, now we use peek. So this method right here, this whole purpose is to display what is now the top of our stack, because at first we stacked 10 and then 20 and then 30. We popped 30, so we want to display what is now currently on top. So we popped 30, so we can expect that the output here is 20. But let's try to traverse through the code first. Alright, so we have our peek. We jump to our peek method. Inside our peek method, we check again if our stack is empty by checking if root is equals to null. This statement is false, so we jump to else. And inside the else statement, we return root.data. So earlier when we popped our value 30, we set our root to the node that has the value of 20. So now when we return root.data, we are going to return the value that is in that specific code, which is 20. That is why we got. Alright, let me just run this code. Alright, so that is why in our print state in our last line of output that we got from our code, the output is top element is 20, because we already popped the 30, which was our top element. So if we pop that, the other one, the next element that follows is 20. So 20 is now our top element. So that is how we implement stacks through linked lists. So thank you so much for watching. And before I end this video, we can see here that we still have an unused method right here, which is empty. But if you really want to use this, we can just call that method right here in our main method. So we add SLL dot is empty. Now in our is empty method, we just put a quick print statement so that we can see the output print. So the list is empty if our root is equals to null, and the list is not. And if our root is not equals to null, then the result we will print list is not empty. So if we run it here, obviously our root is not equal to null, so that's why we printed list is not empty. So that concludes my video about implementing stacks through linked lists. I hope you learned something about this video, and I'll see you guys in the next one.